Welcome back to our seventh and last video of the video series of writing a convolutional neural network for image classification. In this video, I'm not going to do that much of it like a machine learning stuff. We're just going to use a specific package called TQDM in order to add a progress bar to basically increase the verbosity of our training by adding some like information while the model gets trained. So I would jump to the beginning of like basically the beginning cell where I imported the packages, and I'm going to import the package TQDM. Okay, so now I'm going to go down again, and what we need to do here is to literally copy paste the latest version of our training loop, and now we're going to add the capabilities that TQDM adds to our work. The way it works is that we start by epoch in range num epochs, that's for sure. After defining the running loss equal to 0, what we're going to do is starting with the with statement, and we would say with tqdm.tqdm of now the loader needs to be introduced here, the train loader, and this is just for the sake of visualization. We just say units are batch as we will call it tepoch. So it's still one epoch, but we will call it a tepoch. So remember, we started by going into one epoch, but instead of directly going into training, we used a with statement to add the capabilities of TQDM. We wrapped TQDM around the train loader. So right now, instead of enumerating over train loader, you'll see that we're going to enumerate over TQDM. And we called each epoch that is using a TQDM a tepoch, just to highlight the fact that we're using TQDM version of the epoch. Now, our for loop basically goes into the with statement. Let me put the colon sign here. And now for index and x and y in enumerate of, you guessed it, tepoch. In enumerate of tepoch, we're going to be like everything the same, but at the very last sentence here, we're going to have tepoch dot set postfix. And then we're going to say loss is equal to loss dot item. And keep in mind, everything should be under the TQDM. So print and then check accuracy, all of it is under tepoch. So let's just run this, and now you're going to see that our training experience is much more pleasant. Obviously, we have a progress bar. Our batches are increasing. We get some information of how many batches per second we're progressing. What is the loss of every mini batch? And we get an idea of how much time is left for this mini batch to finish. And we also get the progress bar. So the process of training is not going to be as boring as it was before, as we were waiting for these values to get printed. We were getting a lot of information as the model is getting trained, and it's actually a pleasant experience. Keep in mind, I didn't reset the model, so we're basically retraining the model. So it would be interesting to see if by retraining we can get to a higher levels of accuracy, or the accuracy has really plateaued and we're overfitting our model. We're going to see all of that in a glance right now. Perfect. So as you observed, we have experienced a much more number of receiving information during the training. And as you notice, we had an increase of accuracy from 29 to 37 and then 40, which was great. But then it went from 40 to 41, 41.5, 41.8, 42.57, and 42.69. Yeah, it's increasing, but it's not that much of an increase. So we basically can say that we can stop the training perhaps at like epoch 0 here. Keeping epoch 0 is actually epoch number 4 because we retrained the model. But you see the idea of how important it is to add the TQDM. It gives us a lot of important information, and it makes your model to look much more sophisticated with getting this amount of information from it. So I hope you've learned a lot of stuff in this mini video, and as well as the entire video series of writing a convolutional neural network. It was a big deal. We wrote an image classifier by not using fully connected layers. We wrote convolutional neural network models. We took care of writing a data set from scratch, and that is also a big deal because if you learn how to write the PyTorch datasets and write your own model, you're pretty much there. You just need to learn more stuff regarding like what are the different techniques that people use and or have used so far in order to like for example push the boundaries of these classifier to reach higher level of accuracies and not stop at 42%. I told you about how the number of data sets that we have here is not that much, and 42% is still great given that we have less than 80 image per class. But the notion that you have a model that only predicts 42% of the time correctly is not a very good thing to even talk about. So in next videos, we're going to go over different models that are sort of like a state of the art, or even if they're not currently a state of the art, they have been like 2 years ago, 3 years ago, they have been a state of the art, and we're going to basically write them from scratch, and we're going to learn a lot of things from there. Plus, we're going to work a lot on early stop, callbacks, and regularizations. These are techniques that you can utilize and make your models be even better with the current format and make better predictions. So until the next videos, try to um, rebuild what we made in these videos. Leave me comments under these videos, and if in any case you found these videos useful, please support us by subscribing and hitting the like button. Thank you so much. I will see you in the next videos. Bye.